So the next speaker is Basti Bloessl. Basti is a postdoctoral researcher at the Secure Mobile Networking Lab, CMO, of Technical University Darmstadt in Germany. His research is focused on real-time signal processing for software-defined wireless networks, as well as the performance and robustness of vehicular and sensor networks. Since 2017, Bastian is also a project officer of GNU Radio, a popular open software defined radio framework. He contributed several extension modules for modern runtime that makes more efficient use of multi-core processors and accelerators. Well, Basti will today talk about GNU Radio on Android, and I feel that will be very, very popular talk. So let me introduce just what he wants to tell us about. With the ever-increasing performance of smartphones and tablets, they become viable platforms for applications that were in the past only possible on desktops or laptops. In this talk, he will look into using GNU Radio on Android, enabling high mobile SDR applications. While Android applications are mostly implemented in Java, all data processing happens in C++ domain, driven by GNU Radio's parallelized runtime environment. The Android port supports popular USB-based SDR, RTL-SDR, HackRF, and USRP B200 series, and can fully benefit from available accelerators, allowing non-trivial SDR implementations to run in real time on a phone. To show how GNU Radio can be used on Android, we will look into examples that implement an FM and Wi-Fi receiver. Basti, I'm very interested in your talk, and hopefully now the pre-recording will start and can have a great talk to show what it is from this talk.
Okay, so thank you for the introduction, and thank you all for joining the event or watching it on YouTube. So I'm very happy that I can talk a bit about GNU Radio on Android, which is a very interesting topic that I put quite some work into in the last months. So yeah, the goal is to have very mobile software-defined radio applications with GNU Radio, and yeah, I hope I can give you a bit of an overview of the project and yeah, wetten your appetite and hope you have a look into it and build cool stuff. Okay, so first some words about me. I currently work at TU Darmstadt as a researcher in the Secure Mobile Networking Lab. So people there are working a lot with software-defined radio on all kinds of wireless stuff. Not everybody's looking into security. Also people like me who look more in software-defined radio in general and stuff like that. And I'm also involved in the GNU Radio project, where I'm a project officer, and my main interest both with GNU Radio and also at work at TU Darmstadt is building software-defined wireless networks, so highly reprogrammable software-defined networks. In particular, at the moment, I'm looking into the SDR runtime environment, so scheduling on the CPU or maybe also integrating GPUs and stuff like this. Okay, so I wanted to start with a very brief introduction about GNU Radio. So I guess most of you are a bit familiar with it, but I wanted it to be self-contained and just really short. So GNU Radio is a very active open source project. We're a big community with a lot of people that are working in it. It's a real-time signal processing library or framework, and here the real-time part is the important thing. So probably you know a lot of signal processing libraries from Python and MATLAB, but the important thing about GNU Radio is that you can process the data live while you stream it from a device. So it's something you will use. It's the software part of a software-defined radio system. And cool thing about GNU Radio is that it provides the base to build your own applications, and you can extend it through we call it out-of-tree modules, which are third-party extension modules that then often implement a particular technology, like, for example, like Wi-Fi or Zigbee or LoRa or stuff like this. Okay, so this is GNU Radio. And why do you want to, run this on Android? That's the question of the talk. And so as I already mentioned, my goal was to build highly mobile SDR systems. So you can do very mobile measurements, you can do experiments. I hope it's also an interesting option for amateur radio applications. Like so at least the market share of Android is pretty high, and maybe you already have an Android phone and you're carrying it with you all the time. And on the right side, I showed there an example setup. So in this case, it's a B200 Mini from Ethos Research, and you can see it's a very, very small SDR. It's connected directly to my mobile phone, and so you have a very small portable setup where you can do all kinds of cool stuff. And mobile phones are an interesting platform for SDR because, I mean, they are getting better. They are very small, and also if you consider what they are capable of, then it's actually a pretty decent price. So they are battery powered, so the whole thing doesn't need any external power. You have the SDR connected to your phone. You have a very good screen. You have multi-touch input. Often you have quite a lot of storage and very fast storage. You have decent CPUs, GPUs. I will show you how to use them also in the talk. You have good connectivity like Bluetooth, Wi-Fi, cellular. You have sensors like gyros, cameras, GPS, and you have audio in and audio out. So that actually sounds like a pretty decent platform for software-defined radio applications. Okay, so in the beginning, I wanted to give you a bit an overview of what I did, and then dig a bit deeper into the individual topics. So I'm not the first one who looked into getting GNU Radio on Android. A lot of this, what I did, is based on earlier work by Tom Rondeau. So on the right, there's a talk that he gave at GRCon in 5 years ago. He was already looking into this, and I picked up a lot from his stuff and extended it quite a bit, and I hope I made it a bit more accessible. Also, it was bit rotting, so I updated a lot of stuff. And now in this presentation, I usually just tell you about the current state. It's not so much about like the typical academic talk, like this is what Tom did, and then I rewrote this and extended this and blah, blah, blah. So I just tell you the current state of the project. Okay, so currently it supports the most recent version of GNU Radio, that's 3.8. It supports 3 types of SDR, so the Ethos B200 series. It's the small one that I showed you, but also B200, B210, then the HackRF and the RTL-SDR. And as you've seen in the picture before, you can connect them directly to your phone with an OTG cable, and then these are all bus-powered devices. So you have a self-contained system, and your phone powers the SDR. And also a good thing is you don't need to root the device, because often that is a bit complicated, let's say, if you interface hardware from Android. You have to deal with its permission system and stuff like that. And the easy way is often to just root the device, and then you can do whatever you want. But people don't want to do this, and there's also some security implications with this. And with this, you just install the app and nothing else. You don't have to hack or your phone or stuff like this. And it supports Android API level 28. That was introduced with Android 9. This release was called Pi. And this has a market share of a bit above 50%. If you really need it, you could, in theory, reduce this because we don't use any very recent features. So probably you can backport it to API level 26 or something, and then you should have a market share of about 75% of all Android devices that are still in use. And then maybe from Android you already know, that's this Java system, and maybe you have some thoughts about Java and you don't want to use it. But here with GNUradio on Android, everything really happens in C++ domain, so the samples are never, Java never sees the samples. You do all the heavy lifting, and all the performance critical stuff happens in C++ domain. Yeah, and this is something that Tom already built. It's a lot of hardware support for your phone. So he built GNUradio modules that basically allow you to access, for example, the gyroscope, or access the microphone. So out on the speaker, so audio in, audio out, all this stuff works. So it's really very good integration in Android, in the sense that you can really use all these cool hardware of your phone. And since a lot of this stuff is quite complicated to set up, let's say, so until you can really get started to build your own applications and to build your own SDR stuff, you have to install a lot of stuff. We will see this in the following and discuss it a bit more in detail, but to make this as accessible as possible, I also created a Docker container. So that means you have a virtual environment where everything is already installed, and you can get up and running pretty fast, let's say. So it takes some time to compile and download all this stuff for Android until you have it on your disk. But once you have the container, you should be up and running pretty quickly. And it comes with hopefully cool example apps for FM radio, like the Hello World FM receiver, and wireless LAN receiver. So the wireless LAN receiver shows you that also non-trivial applications are certainly possible on phones. Okay, so what's my motivation for getting GNUradio running? Because if you type SDR in the Google Play Store, then there will be all kinds of apps that are already there. But the biggest difference, in my opinion, is that with GNUradio, the goal is not to ship the app that can receive everything, but the goal with GNUradio is that you really have a library, a framework that you can use to build all kinds of apps. So it's general purpose platform, framework, or base that you can use in your own apps. A lot of these apps here, they are developed sometimes in Java, so they are not really efficient. They only implement rather straightforward, simple technologies. And they are application specific, let's say. So in the sense that if you want to implement a new technology, then you have to basically start from scratch again or rewrite everything. And some of these apps are open source, some are not. GNUradio obviously, and everything I present obviously is, because otherwise it wouldn't be really useful for you. Okay, so that's the differentiating factor, and that's also why there is no GNUradio app about to show up in the App Store. I don't plan to release something there. I want to really ship the toolchain that you can use to build your own SDR apps. Okay, so I hope that some SDR apps that use GNUradio will show up there in the future. So that's the goal. Okay, so I'm in no way an Android expert, but in any way, I want to give you a brief and very simplistic overview of the system. So it's built heavily on Linux. It's cool because I know a thing or two about Linux. It has a slightly different security architecture. That means the apps are sandboxed. They are supposed not to interfere with each other and not to read each other's data. And there's a more complex or permission system. So every app has to ask if it is allowed to access external storage, or if it's allowed to access USB or whatever. So it's more fine granular than on a normal, typical Linux installation. And as I already mentioned, apps are mainly written in Java, or more recently also Kotlin, which is the new language, which is now also natively supported. And the whole stack looks a bit like it's depicted on the right. At the very bottom, there's the Linux kernel. Then there are some libraries, so that means some compiled shared objects like the linker or libc or whatever you might know. So this is compiled stuff. On top of it is the Java framework or the application framework. That means if you want to spawn an application, if you want to draw a button, if you have a notification, so all that kind of stuff that you know from your phone, there's a Java framework, and then you have the apps. And the cool thing is now that the apps can directly interface this compiled shared objects or libraries through the Java native interface. So that's a bit depicted in here through this white box that points toward this library. So there's a bunch of system libraries, but your app that you are creating, it can ship also shared libraries that you can use in your application. So with GNU Radio, what this means is that the app includes libGNUradio shared object, libGNUradio FFT, all these shared libraries that you usually build on your PC. They are part of the application that you install on your phone. And then your app can use it through Java native interface, JNI. Okay, so now the whole process, if we get an overview of what you'd have to do in order to build a GNU Radio application for Android, is this. So this is the overview, and then we discuss it a bit more in detail. So first of all, you'd have to download the Android development kit and the NDK, which is the native development kit. And this is a complete C compiler, linker, everything that you need to cross-compile C or C++ for Android. So you cannot just use your GDB, CLang, or your normal compilers that are already part of your system, but you need some that are specific for Android, and you have to download them. Then you have to build GNU Radio and all its dependencies, for Android. And if you already compiled GNU Radio from source, you know there are quite some dependencies, so that can be a bit of a hassle. We talk a bit more detail about it later. And then once you have all these libraries ready, so that means that on the right, these user libraries would be ready, then you can use Android Studio. It's a very good IDE actually to build Java applications. And these applications that you build are then, they link against these GNU Radio libraries. So this is basically a very simple CMake project. And then you create an app, which is usually bundled in an APK. And this APK then has your bit of Java code, maybe for GUI or something like this, and all these libraries included. So, so just to be clear, with on Android, you don't install GNU Radio system-wide, or so basically that these shared objects are available for every application or something. No, every application always includes all these shared libraries that it needs. So if you have, let's say, 3 GNU Radio apps installed on your phone, you'd have these shared libraries also 3 times on your phone. Sounds a bit strange, but also it avoids all dependency hassles or conflicts. Okay, so that's the workflow. And just to give you a bit of an overview, the first step, or one of the first steps, was cross-compiling GNU Radio and all its dependencies. And if you, so this is what I basically did. These are all the libraries. On the left are the normal library dependencies. That's something like Boost, Thrift, FFT library. And some of them are quite straightforward. Some of them are a bit more complicated, so they needed patching because not all of them are designed to be cross-compiled for Android or be run on Android. So I had to update some of those, had to update GNU Radio. Then on the right bottom side, there is all this hardware-related stuff. As I said, these are these 3 SDRs from Atos, HackRF, and the RTL-SDR. I was focusing obviously on this bus-powered stuff, so that I needed libUSB. And gr-Osmo SDR is the GNU Radio driver for, at least that I used for HackRF and RTL-SDR. And I also cross-compiled some out-of-tree modules to have some nice demo applications. So these are out of 3 modules for wireless LAN, for Zigbee. Then gr-clenabled is Tom's Android stuff, hardware stuff, like the speakers and microphone. And then SCL enabled is OpenCL blocks that I will go a bit into detail later. And gr-clenabled is some performance benchmarking tools that I developed a while back. So as you can see, this is pretty a lot of stuff, a lot of dependencies, a lot of projects. And to somehow keep that tractable or maintainable, or to keep sanity, if you want to work on that, I created a GitHub repository. And this repository, it contains a lot of submodules. So what it does, it points to compatible versions of these libraries. And in the case, if these libraries need patching, then it points to something that is already patched. So if you just clone this whole thing, you have a directory structure with basically all the libraries, GNUradio, all its dependencies in a patched version on your disk. And then it features build scripts that is then basically using the NDK to cross-compile everything. And so the old version only supported the 32-bit ARM CPUs, and now this also includes 64-bit. So this is ARM version 8, basically. Exactly. So also the build, the NDK, so getting Android Studio is quite complicated, and also you have to have several specific dependencies on your build system available. So even with these build scripts and this Git repository, I figured that it's still not really accessible and still really hard to set up, and I wanted to make it as easy as possible. So basically I also created a Docker file that is automatically setting up a complete development environment on your PC. And this Docker file is also included. So that means if you want to get started, you just have to type these 4 commands, basically get the repository to get the Docker file, build this Docker container. So it's downloading the Android Studio, the Git repository that you've seen, some example applications. It's setting up Android Studio. It's cross-compiling everything. So it's basically executing all these build scripts. And so when you're set up, when this is run, you can really start developing. You should have everything on your disk. Only drawback is needs quite some storage. I think it was a 15 or 17 gigabyte, the container. So the container is pretty big. The biggest stuff is all this Android dependencies, the IDE and the toolchains. So I need some space. And it's downloading quite a lot of stuff. So you should have some proper connectivity. Yeah, so when everything is set up, the container, you can start Android Studio, and with this is basically the IDE to develop your Android application. And part of this Android application is then some C++ thing that is then, in essence, only setting up a GNUradio flow graph. The screenshot here is just to give you a bit of an idea. It shows parts of the Wi-Fi receiver, and it's very close to what you might know if you ever looked at the actual script. That, for example, if you create a flow graph with GNUradio companion and looked at the script that it is generating, that you execute, these are often some Python scripts or stuff like this. They use the blocks of GNUradio and then glue them together, like creating a top block and creating blocks and connecting these blocks and then starting the top block. And the very same thing you do here as part of the Android application. And that is actually the only the complicated or most complicated part, that you have to write some C++ to instantiate the blocks, connect them, and run them. So this is done in C++ as part of the Android application. But as I said, I have several GNUradio Android applications as an example, so you don't have to start from scratch. You can use an application and adapt it to your needs. So then everything is there. You just have to instantiate different blocks. So I hope this should be also rather straightforward. Okay, so I wanted to tell you a bit more about the radio front ends, because it's a very interesting thing, and it might be that people are interested in porting or adding support for different hardware, and there's some bits you have to know. The most important thing is that usually these USB devices, they use libUSB, so they are all the device drivers are based on libUSB, and libUSB on Linux uses USBFS. Maybe you know, I think it's dev USB or something like the USB. The device nodes are part of the file system, and you can basically interact with them through the file system. And that's the way it works on Linux. And on Android, this is not allowed because of their security concept. You are not allowed to just traverse the device tree or stuff like that. You have to use the Android USB manager. So they added an entity in between you and the file system. And you can ask the USB manager about the devices that are connected and see, for example, check the product ID and the device a manufacturer to see if this is an RTL-SDR or a HackRF, for example. And then this USB manager, it gives you a file descriptor. So it already opens this device file basically, and then you only are allowed to interact with this file descriptor. So it's a bit different than it is on Linux. It's not much different. Basically, the procedure to look for the device and to open the device has to be adapted. So that means that all these, if you, for example, want to add support for the AirSpy or something like this, you have to keep this in mind and probably have to do some minor modifications to the driver and do it the Android way, so that you don't have to root your device. What you could actually do in theory is just use the normal USB driver from Linux and root your device and then access the file system directly. So that should work, but that's something I didn't want to do, because then I think not a lot of people would actually do this. I wanted to do it properly, let's say. Okay, so also, since there's already these three devices ported, you can have a look at what I did to add support for these devices, so it might be easier for the rest. Okay. Then there's interesting differences between a normal Linux system and Android, also from runtime configuration, because, for example, Android, they don't have CPU affinity, for example. So you cannot say, hey, GNU Radio run this thread on this particular core. So first of all, the ARM cores, they might be very different. There are different types of cores, then the operating system might switch them on and off. So you're not supposed to really tell the operating system or Android where you want to have this scheduled. So that's not possible. Same thing is for real-time priority. Actually, in last GRCom, I had a paper where I looked into the different Linux schedulers, so like the CFS, the normal scheduler that every applications use, and then there's some real-time scheduling policies. And on Linux, they can provide quite some improvement. On Android, you're not allowed to use them, because on Android, doesn't want you to mess with that, because, for example, it uses real-time for audio and stuff like this to avoid any glitches, so that audio is broken, and they don't want any application to mess with that. So that's not possible. What you can do is use the nice value just as usual. The nice value, it gives basically a priority to a thread or a process. And on Android, it's usually set up like all this audio and visual stuff has the highest priority, because you want that your application feels smooth. And so they usually give the highest priority to visuals and audio. And in our case, it's exactly the opposite. So I set the nice value for this GNU Radio thread, so that all the signal and this DSP stuff all gets the most CPU time and has the highest priority. And then something that a normal Linux system doesn't have is game mode. So you can add your application in game mode, and then it gets even more resources, so a bigger share of CPU time. And also, Android suspends some other applications to disk, so that you have more RAM. Usually that's not the problem. You're only interested in CPU. So game mode Depends on how it's implemented, but might do a lot of stuff. But at least it assures that you have higher priority and get a bigger share of the CPU, so you can enable this. Even though I didn't manage to trigger or load the phone in a way that I did see a big improvement or stuff like this. But anyway, I think it's worth mentioning that this is an option. Okay, so when you develop your application, this GUI things and stuff like the window notifications, some ways to interact with it. You have to do this in Java because you want to draw something on the screen. So there's always a Java component to it, and then there's GNU Radio running in the C++ domain. And now the question is how you can interact, how you can exchange messages, how you can configure GNU Radio, for example, set parameters, query parameters. And there are quite a lot of different ways how you could do that. So probably if you are familiar with GNU Radio, the most popular might be control port. So this is it's designed for interacting with flow graphs remotely. So that means this works over TCP IP. So this could also be run on a different host. So basically Android and Java and C++ talk through TCP IP sockets with each other, and control board adds on top all this stuff for setting parameters, querying parameters, or getting data. So for example, on the right hand side, you see an example FM receiver, and it plots the spectrum, and the samples are pulled from GNU Radio through a control port probe that just whenever I have the time to draw a new frame in the GUI, I ask GNU Radio to give me some new samples, and then I plot it. And that's everything. So that's natively supported. You could also, so GNU Radio has this support for PMTs, polymorphic types, on asynchronous messages. So asynchronous message passing. And this also works. You just have to write your own C++ function. So JNI interface for every call you want to make. So that is maybe not the most accessible thing. If you want to stream data, there's also GNU Radio comes with UDP and TCP sources and things. You just could use this as well if you want to stream data to user space. This was not really required in my case because I just wanted to pull data, for example, to set to draw the spectrum whenever I had time, and if I didn't want to get a continuous stream because I didn't know how often I can have the time to refresh this plot. Or another mechanism that's also supported in GNU Radio, and there's also example use cases or example uses in the apps that I provide, is 0MQ. So that means you can use normal 0MQ library. It's like maybe UDP or TCP, but it's a bit easier to handle. You don't have to open the server before client, and also it's a bit more robust, maybe a bit more convenient to use. So, but all these different mechanisms are supported. And there, for all these are also examples in the applications. Okay, so this gives you basic GNU Radio, everything you need to build your app. And now the rest of the talk is about making it better or improving performance. First thing is VOLK. It's was part of GNU Radio. Now it's a separate project. It allows you to access single instruction, or it eases the use of single instruction multiple data instructions of your PC. So this, maybe you know it from CPU extensions like AVX, SSE, or on ARM. So that's in the case of GNU Radio is the important thing. It's Neon, and it's it provides optimized implementations for common signal processing functions like adding something, multiplying something, doing an FFT or something. And usually there's always a generic C implementation that works on every platform, and then there are optimized implementations, for example, using Neon. And what the on a Linux system, you'd have the Android profile application, which just tests every implementation that's compatible with your CPU, and makes a config file that tells you what is the best or most performant implementation for your CPU, and then it will select this. And what I did is basically porting this to Android. So that means I have a custom Android application that's also running VOLK profile. So it profiles all of these SIMD implementations on your smartphone. And actually, even though it just benchmarks all of them, and then it also has this VOLK config file that keeps track of the one with the best performance. And I also adapted GNUradio and everything so that this file that you generate with the app is then used by all other GNUradio applications that are on the system. So it's writing these config files in external storage. That's usually, it's not, most of the time it's not external, it's just a certain partition on your phone, or sometimes if you can plug in an SD card, then it might be the SD card. But anyway, there's some external storage, and all applications that ask for this permission can read from it. And I place the config file there, and then whatever GNUradio application that you might have on your phone will use the instruction that performs best. So here's a bit an overview of the performance of ARM v8 and ARM v7. And the only thing it's supposed to tell you is that there are it really makes sense to profile and to use VOLK, because through this you can get, in many cases, a performance improvement. And here the best one is about 8 times faster for ARM v8. And for ARM v7, the stats might be totally different, but in any way, there are a lot of functions that really benefit from this. So apart from SIMD instructions, you can also use the GPU. Actually, the GPU, or OpenCL, which is the framework to access this GPU usually, is not part of the Android API. Android only supports Vulkan, but there are no GNUradio Vulkan blocks at the moment. There are only OpenCL blocks. Yet a lot of these smartphones, they support OpenCL, even full profile, like the normal GPU on your PC. And you can make use of this. So it's a bit tricky, because since it's not part of Android, you can just build it with the SDK. But you usually your phone has all these libOpenCL, all these libraries on their phone, so you can just copy them from the phone to your Android applications and then access it as usual. Here on the right, you see, for example, I have a OnePlus 5T, and it has a Snapdragon processor, and this comes with an Adreno GPU, and here in my Android application I can just use it, and then I can use this GNUradio out of tree module gr-clenabled to just run GPU accelerated GNUradio blocks also on my phone. This is pretty awesome. It's awesome, but the use is pretty limited. There's a lot of work because GNUradio currently has some limitations. It doesn't support zero copy, so using the GPU always introduces some memory overheads. There are a lot of papers on that, and I don't want to go into the detail, but there are only, I did performance evaluations for GPU versus CPU, and there are only a few cases where it's actually that useful. So first of all, with a GPU, you have to increase the buffer size to avoid overhead per transaction, and then there are only several functions that really benefit from it. Here's an example of complex to magnitude, which is always faster on the CPU, and then getting the argument of a complex number is mostly faster on the GPU. So this is one of the few cases where you really get a benefit, but you have to look for them, to be honest. Okay, so then I already talked about the example applications. I have a video there, and they demonstrate different things. The FM receiver is kind of the hello world. It tells you how to use the speaker of your Android device. It shows you how to use the GUI. It has this control board probe that I mentioned, and it has this knob that sets the frequency of it. So this tells you how to use this stuff. And to show that it's not only possible to have trivial applications, but really to have something more complex also running on your phone, I made a GNUradio wireless LAN receiver, and this is built on my 802.11 AGB transceiver. And yeah, if it really, which bandwidth it can sustain depends on your phone. What's shown in the screenshot is 10 or 5 megahertz. I don't know. At least my phone was not able to cope with 20 megahertz. I have a tablet with a state-of-the-art Snapdragon processor, which is doing much better. And Also, my phone, if I use normal sample resolution, didn't have only has USB 2, so it couldn't sustain even the bus connection was not fast enough. But more recent processors come with USB 3, so that's also not a problem. And yeah, stuff gets better over time. So yeah, I hope in some years we can do more fancy applications. Okay, so to conclude, I think the project is pretty complete. I guess most or all, I don't know, technical challenges are solved. I try to make it accessible with Docker. There are example applications, and I would love to hear some opinions or feedback. So is there something missing? What would you like to see? More examples for particular things or other applications? I mean, I cannot just build all applications that are out there, but the future of the project mainly depends on, are people actually interested in this, because there's a non-zero time to maintain all of this, and if it's really worth this to put this effort into it mainly depends on if people are interested. Okay, so most important thing is the link to the repository, and then there's also a link to my Twitter if you're interested. And so thank you for your attention, and I'm open for questions. Thanks.
Okay, we are now back. Thank you very much to the audience to listen and to watch this nice presentation from Basti Bloessl. Are there any further questions? I see that I saw that there are a lot of writing chat commands. Are there any further questions which should be answered live now? We have a little bit time for it. Oh, Basti, are you able to answer one of the commands in the chat here and live? Give some additions on it.
Yeah, for example, I wasn't sure if I got the question right about the benefit of GPU acceleration, because somebody asked about the benefit of the gr-clenabled module, and there. So first of all, I'm not really sure if I got the question right, but as far as I understood, so the current situation that is, it's not really easy to get a benefit from GPU acceleration at the moment, and this is basically two parts to it. First one is that GNU Radio doesn't really have a good support from it, so there's always an overhead in copying data back and forth to the GPU. There's always one unnecessary copy that's a limitation of the current runtime, but we're working on this. And the second part is that the GPU provides the biggest benefit if you always send big chunks of data to the GPU. And GNU Radio's scheduler works like it's processing data as soon as it's available. So that means that you can set very big buffers, but doesn't necessarily have to mean that GNU Radio actually always uses these big buffers. Maybe it just has few samples available and decides, oh, let's already run this, for example. So these are the two things that are currently make it hard to really get a benefit from it. And it also depends on the actual function that you're trying to compute. For example, what I've seen is that trigonometric functions are good candidates, let's say. But also what might be interesting is that, I mean, this improves with GNU Radio, and currently there's a lot of discussion and a lot of development going on in GNU Radio that's trying to make the runtime better and allow ease integration of these accelerators, and hopefully this will improve in the future. So this is at the moment more like a tech demo and not really something that is incredibly helpful as it is right now.
But when we look at the chat, we saw a lot of good ideas how to apply this. So it is a very good idea to have it.
Yeah.
It is really working. Yeah.
Yeah, that is really nice to see so many ideas, because that is something I'm very interested in, because everything depends on if people are interested in it, if there are actual use cases for it. So then that is basically decides if it's worth continuing the project, putting time into maintaining it, and all the kind of stuff. And it's very very good to know what people have in mind it might be used for, and to see where it could be improved or where it's worth to put some more time and effort into it.
Okay, I think
Okay, I think we have
I'm not quite sure if my network is still available.
Now it's back again.
Okay, we can hear you again.
Okay.
Okay.
Yeah, I think we should open the discussion we had in background about what is the need. The community must use it, and I invite everybody from the community to use GNU Radio on Android.
Well, there seem to be some audio problems.
Yeah.
There are some more questions. For example, from Severin, what about Pluto SDR support? Delta Lima 9 Whiskey here in Munich.
Yeah, I seen the question, and that's I have to have a look how complicated it is to include the Pluto, but yeah, it's true. I mean, I focused on the SDRs that just were on my desk, but probably I should also give a shot for the Pluto. But I would assume that the USB backend of gr-IIO or IIO in general is also based on libUSB, so hopefully it should be doable. But I didn't have a detailed look on the driver, so I cannot say how much work it is. But it's interesting to know again that there's interest, so I can have a look at it and see how complicated it would be. The only thing that might require some more time is because the driver infrastructure is a bit different compared to the other SDRs, because they just have a USB driver for the SDR, and with the Pluto you use this industrial I/O interface, and I'm not really sure how it's implemented in detail. So for the Pluto you have this USB backend of industrial I/O, so it's a bit a different driver stack. I will have to see if I can get it running.
Okay, hopefully my audio is now okay back again. Thank you. Well, I want to remind, one of the discussion point was on FreeDV and Codec 2. It's a very interesting part of the chat that it could be a good application to have a FreeDV codec together with a radio. HackRF is mentioned, or maybe Pluto when it works. So it could be a good extension for all of that.
Okay, to be honest, I have to admit, so I'm not really an expert into that. So just seeing this as a potential or application for it, I'd have to look it up. So I really cannot say anything about how realistic that would be, or if I can.
Yeah, so some advertising. I had a German video here in the conference about application of FreeDV and Codec 2. I explained a little bit how it works, and now it is very important that the FreeDV group is working on application for satellite communication QO100. So this will be very nice, since we have an 8 kilohertz bandwidth within 1.6 kilohertz really bandwidth used. So this will be very interesting if we can apply it.
Mm-hmm.
Okay. Are there any further questions?
Yeah, Severin is asking a question. Another idea about a whisper beacon for QO100 with HackRF.
Okay, gets to the list. I mean, let's say everything gets mostly pretty easy if there's already a GNU Radio transceiver for it. I guess for this, it should be really straightforward, or it even exists, I'm not really sure. And if there's already a GNU Radio module that implements this functionality or flow graph, then it should really normally very easy to get it going. If not, it's like developing a new Android application and then putting it on Android. Yeah, but I'm not really sure about if a module for this exists, and if it uses, that is maybe one point that also I'm not sure if I mentioned in the talk, is that on Android you currently only run the C++ stuff. So that means if there are some modules, for example, that you make heavy use of Python implementations, and they cannot be just used on Android, but you have to use the normal or the more common C++ blocks, let's say. Yeah.
Well, many of these ham radio applications are based on an audio processing. So we can divide the total process chain into the parts using the radio and preparing the radio stream. On the other hand, we have the audio stream, and therefore you find a lot of applications which can be implemented and maybe on Android as well for these audio processing. But I think Whisper is not the main purpose of QO100, since you don't need this power. Whisper needs a very excellent frequency, and it must be pure stable within only a few hertz within 2 minutes, and you can't decode it. So I think this will be a very hard recommendation for the local oscillators to fulfill these requirements. And I don't think that it's a good idea to put all the power into this.
Now since you mention it, I think so. What is also possible is that you don't necessarily only have to use it as an SDR framework, but it should also be doable. And that, for example, you have a normal radio with an audio output, and since then you have your microphone input on the Android phone, you could just pipe just the audio signal. There's already the demodulated signal onto your phone, and then have GNU Radio work on the audio data that it receives. So this would also be an application. Then you probably don't have the benefit of this very portable, self-contained setup, but it's also would be possible to use it like this.
Okay, thank you very much. So I have a look if there are some further questions or comments from the audience in the chat. I don't see any new questions.
Yeah, so, well, DD5JFK, ask a question. Jakob?
Okay.
Whisper Beacon and QO100 kind of defeats the purpose of Whisper, doesn't it? Yeah, well.
Okay, Markus Müller mentioned something about the oscillators for satellite transverters. Yeah.
Yeah, worth observing. Yeah.
Okay, so I think we have a few moments for the next talk. Until 3 o'clock it will be starting. So I asked the video conferencing, Sebastian, can you take it over? I think, first of all, before we finish, we have to make a big applause for Basti. It was an excellent talk.
Thanks.
Thank you very much for your kindness to come here and to let the community know what it is working on Android now. It's excellent talk. Thank you very much. And so we are now finishing, and Sebastian, you can take it over and have us a little time. I think it's a time to get the coffee now.